Okay, I was going to start with this, and we do have a doozy today. Then I'll tell you how you can memorize this stuff. But let's start with Friday and do a little bit of memorization on Friday. Not memorization. This is what I would have done if I was here Friday. If I wasn't a bum, which I was. Big mistake. Playing with my telescope outside, watching the eclipse till 3 in the morning, and then hitting the snooze button in the morning. That's what you got that right. Did you see the message on? Not lying. It's not a great excuse, but it happened. Hey, why did I do this? What's theta plus theta? 2 theta. So this is a way of deriving the sum rule. Wrong. Deriving the double angle rule, tricking yourself using the sum rule, but just summing the same angle to itself. I said that the way I wanted to. So what's sine? It's sine cosine, right? But these angles aren't different, all right? The second angle is the same as the first. It's okay. And then what's sine? What do you put? Plus or minus in between? What do you put? Plus. You have to know this anyway. You have to know the sum rule. Oh, then lo and behold, it's sine of the second angle, cosine of the first, but those are the same. So what do I have? I have sine cosine twice. I have 2 of them. So therefore, the sine double angle formula is this. 2 sine cosine. So when you see how it's derived, sometimes it helps in memorization. And if you can't memorize it, but you know the sum rule, you can derive it on the go, as you're in the middle of a question. Same thing with cosine. We could use the sum rule, but sum the same angle to itself, and then trick yourself using the cosine rule. All right, and what's cosine? Is it sine cosine or is it cosine cosine? It's cosine cosine, and there is no sine sine ones. Well, the second part's sine sine, I guess, but it's cosine cosine. And what's the sign, S-I-G-N, in between? Minus. And then this is the only reason that there are 3 of these. Here's the first one. I'm only going to derive another one. The reason there are 3 of these is the answer to this. What can I change sine squared to? What can I change sine squared to? 1. Anyone? 1 minus cosine squared. Or what can I change cosine squared to? 1 minus sine. Let's do that. That's a little bit easier. I could change this to 1 minus sine squared and then create a different version of this identity. Just using the Pythagorean identities. That's where the 1 minus 2 sine squared comes in. So if you can remember the first one, you can derive the other 2 by a quick Pythag. Got it? Okay, and then last but not least, tan theta plus theta. The numerator is sum. So it's tan plus tan. And then it's over 1 minus tan tan. So there's Thursday's rules turning into Friday's rules. All right? And that's what I would have done if I was here. And then I'm going to be honest, 4th hour said, let's pick on 4th hour a little bit. I didn't understand any of this when it came to Friday's stuff. You had 2 videos, actually 3, by Cooper. I gave you printed out notes. And really what Friday is the same as Thursday and today, just using different formulas. You got to trick yourself. You got to recognize them. Use them, blah, blah, blah. Replace, substitution. It's all the same actions, but just a different identity being used. So that's why we do want you to have these memorized so that you can recognize quicker. If you don't have them memorized, you won't be able to recognize. All right, now let's climb into your head here. Aren't these pretty much the same? Aren't these pretty much the same? Right? Right? So if I memorized one, I got the other one. By the way, this is going to be a problem because you do have to make a choice on this. I'll tell you how you choose this. That's tough. All right, but here's what I always do. Sine hates cosine. You're really negative. I don't like you. And cosine, you know what? Forget you sine. I really have a positive outlook about myself. Got it? Isn't that pretty easy? And then this one is actually easy, but I will never use it. If I don't have to, I will never use that one. I would never, because it's way more complicated than the other two. But what is tan? You just wrote it as a rule. What's the quotient rule of tan? Tan is what? Sine over cosine. What would happen with the twos? The twos would cancel, and then isn't that just the top and bottom? Or isn't that sine over cosine? So that's pretty easy if you can get sine and cosine. And then after that, I think what happens is if you multiply by 1 minus cosine top and bottom, we can get one of these two left over. All right, and then a Pythagorean identity. But that's not real practical to derive. So you know what? You just got to get these memorized. I will tell you this though. What the heck just happened there? All right, freaking me out, man. If I had a choice, that's the easiest of the three. Why? Because the denominator is less complicated. All right, now for memorization, I just asked Mrs. Gray, do we memorize all three of these? I mean, come on. And she goes, yeah, we'll do it tomorrow. We'll just test them out. So, all right, you're going to be the same as everyone else, because what are we in? You said it. Just lip it, though. We don't know what he said, all right? But he's right. Okay, so we got to do it. Otherwise, we'll get in trouble, and they'll show up. You know who that is. Gestapo. All right, so here we go. Are you okay? I like how your hands are folded. Should be a rule. Hands folded until we're ready to go. All right, nice. A rule follower. Nice. And then someone just gave me the two birds. I'm just kidding. Did you see that? All right. I had first and second hour do that. Every time they point to a question, hey, Mr. Samuelis, they always use the you-know-what finger. Why do I put this stuff into videos? Anyway. I try to get in trouble. See? So wouldn't you agree that this is sine of 45 divided by 2? Right? Okay. So this has a little bit uniqueness here. Okay, and then by the way, here's my thing. Here's what I was telling you. You have to choose the plus and minus. And then here's what it has to do with, everyone. It has to do with ASTC. It really does. And then I'm going to highlight this, maybe in blue. This choice. You got to know, where is your angle located before you start using your formula? What quadrant is it in? All right, well, this first one is not a big deal. What quadrant is 22.5 degrees in? So what sine of a quadrant 1 angle? What sine of a quadrant? Positive or negative? So you choose the positive. That's where this comes into play, though. Because this could be a different angle measure, and then a half angle. This might be in quadrant 3, and I got to use the quadrant half angle formula. It'd be kind of stupid. Well, 300's in 4. I'm trying to think. 240. What's half of 240? I'm trying to think of like 150, 300. I'm trying to come up with ones that would actually work, and I can't really think of any. Because half of 120 is 60. Why wouldn't you just do the 120 thing? It's really not a lot of practicality with the half angle formula. But anyway. And then here's my help in memorization. This is only cosines in here. Oh, sine hates cosine. So it's 1 minus you cosine. 45 goes in there all over 2. So that's how I got my memorization down. So numero uno, you must choose the sine based off of what you're ultimately taking the trig of. Then you go and, plug this in to the formula here. And that's what goes in there. Sometimes students have a hard time how this all works out. And then I'll show you how you simplify. 1 minus root 2 over 2. Come on, if you don't know that. And then this is what I do. It actually takes care of two things. I'm going to keep this underneath the radical, and I'm going to multiply. This is like multiplying by radical 2 over radical 2. but I'm going to keep them underneath that umbrella, and it's the same thing. All right? So really, I multiply by root 2 over root 2, but, get it figured out there. And then the reason is, what's the bottom become? What's 2 times 2? What's the square root of 4? So that's the free 2, and then this becomes root 2 minus root 2. And it is a double root in there, that little thing there. And then you leave it, and that's it. Okay? Got it? So usage of the formula, just use it correctly. All right? And then this one, I swear to dog, I use that third one. I don't care that the first one has all cosines. It also has a plus minus choice. And then it also has a radical over a radical, which requires some tougher rationalization. This is why I choose my easiest. And I might still have to rationalize, and I don't care. I'll still deal with it. But before I do that, I got to figure out what the heck I'm dealing with. And it's tan. I'll stay green for a second. Oh, I should be green. St. Patrick's Day, right? Should do a series of greens. All right, and then what is this? It's either, and this infuriates me. It's 7 pi over what over 2? It's either 16 or 4. What's the denominator of that little fraction? This is either a 16 or a 4. Which one is it? Flip a coin. Shouldn't be a flip of a coin. We should know that it's 4. First of all, we should know that it's one of our, the whole point of this is they're trying to get measures that are in your unit circle. But the second thing is 7 pi over 4 over 2 is 7 pi over 8. All right? Now, let's pretend I had to make a choice, and I used the first one. This is my point. If I were to make a choice, what would it be, positive or negative? What's tan of 7 pi over 8? What should that be, a positive or a negative? It should be a negative because what quadrant is that in? 2. So when you choose that first formula, you got to choose the negative. This one will give you a negative. You don't have to make any choices at all. That's another reason why we choose the second or the third. If it's supposed to be negative, it will be a negative. You don't have to make choices. Do you understand what I'm saying? Do you understand why I would never, ever, ever choose this one? Ever. Okay? I think that one's the first one that comes about, and then through rationalization and Pythagorean identities, the other two come out. And I don't feel like covering that right now. All right, so what do we got? All right, this one, I had a hard time memorizing this last hour. So it's 1 minus cosine 7 pi over 4 over sine 7 pi over 4. And then I'm going to have the same thing that I had in that previous one. What's the cosine of 7 pi over 4? Positive or negative? 3, 2, 1, go. No answer. Mondays. Plus I put them in rows. They're all mad. I tricked them too, so they're mad at me. Positive or negative? Big yawn back there. Huge yawn. And then over, what's sine of 7 pi over 4? Negative root 2 over 2. And then as I was blabbering, I said I'd do the same thing I did on a previous one. I got to move this. It's always so scary to move this because there's barely any room on this thing to grab. Okay, move that down there. All right, 2. Now a 2 on the outside. Because what that does is it gets rid of this radical. So this is 2, not radical, fraction within a fraction. We're going to get rid of the radical next. Doink. Okay, so that gets rid of the fractions. Then I'm going to rationalize. I'm going to grab a different color just for fun. And I've decided to multiply by a negative top and bottom just to get a free 2 on the bottom. A positive. And then when I look at the top, I get negative 2 root 2. And then what's negative times a negative? What's root 2 times root 2? 2. And then this ends up being, no, don't go this far, and then cancel incorrectly. By the way, what's negative root 2 plus 1? Does that result in a positive answer or a negative answer? Negative, because 1 is the square root of 1. So the square root of 2 is larger than the square root of 1. You have a larger negative than positive. So what I was trying to get to the point was this does result in a negative answer, and it will happen naturally. You don't have to make a choice. That's why I would never choose that first formula, ever. This is just formula recognition. So this is, which one is this, sine or cosine? Sine. And what is it? It's sine of this theta divided by 2, which this theta is 170. What's 170 divided by 2? Somebody yelled out 85. Is 85 on our unit circle? Is that something I can evaluate next without a calculator? Circle it up then. It's just the point of, can you identify the identity correctly? Can you identify what's going, the moving parts in the identity? What are the parts? What is happening? Next one. Which one is this? Which one looks like this? This is tan. Is it for sure? It's the middle one, right? I don't choose that middle one because your denominator is more complicated. That's when I have a choice, but I don't have a choice. I must recognize. And then what's 320 divided by 2? Is 160 on our unit circle? Then that's the answer. If it was like 150, then I could evaluate and I go a step further. I do like those sometimes. But yeah. It would be kind of stupid to ask those. And then this one's weird, all right? And this is where I have to make some choices. Okay. We do have to worry about this because I wish this said that you know what? You want to get nuts? Let's get nuts. Yeah, let's get nuts. You want to get nuts? Let's go crazy. Let's blow this stuff up, man. Let's blow this place up. All right, let's say sine of what? Let's sine of x is less than 0. Because I didn't like what happened. I want the hardest thing that could happen to you during the notes. So what quadrant is both? Oh wait, yeah, so 3. Oh no, no, never mind. Because what's half of 180? What's half of 270? This is what I want to have happen. All right, so what quadrant is x in? What quadrant is x in? If both cosine and sine are negative, what quadrant? 3. 3. All right, so cosine is negative 5/8. And then, yeah, I got mean. You want to get nuts here? I got nuts on you here. And then it's Pythagorean theorem. So it's 8 squared, which is 64, minus 5 squared, which is 25. Negative squared are positive, and that equals 39, and it's square root of it. I don't know why I wrote all that. I told you I'm not teaching you the Pythagorean theorem anymore. If you can't do the Pythagorean theorem, this is the problem. It's not this class. If you're still bamboozled about the quadratic form. Quadratic? Anyone want to sing? What is happening? Anyway, sorry. Going crazy here. All right. Anyway, but yeah, Pythagorean theorem. Know it. All right. So this is why I did this. Oh. So what is sine of x over 2? This is why I did it. And we had this discussion last hour, but our angle was in quadrant 2. What's half of a quadrant 2 angle measure? What's half of 180? What's half of 180? What's half of 90? So that half, it would be between 90 and 45. So what quadrant is that? What quadrant is that? 1. So they had all quadrant 1 answers. They were good. I stepped it up a little bit. I don't know where this is at, but it's between 180 and 270. What's half of 180? 90. What's half of 270? So your answer, your angle is guaranteed to be between 90 and 135 when you do x over 2, when you take half of these angle measures. Got it? Got it? The problem with sine is that's my first choice, but is it a problem? What's sine of a quadrant 2 angle measure? What's sine of a quadrant 2 angle measure? Positive. So for sine, I choose the positive. This is why I did this, because this is the hardest thing that you could run in. And then cosine hated. They hate cosine. And then this is negative 5/8. So the sine rule is 1 minus cosine. All right? So I will put that there for a second. So this was the whole thing. This was that whole spiel. I had to know because theta or x is in quadrant 3. X over 2 is in quadrant 2. But sine of a quadrant 2 angle measure is still positive. I'm okay. All right, that was deserved to be reiterated. And then you know what? This is 8 over 8. That becomes 13 over 8 over 2. You should do that. What's 13 over 8 over 2? 13 over 16, which is root 13 over 4. Reason I did that simplified real fast, we're going to have a similar simplification with cosine. But here's the kicker. The kicker is cosine in quadrant 2 is a negative. So when I do the cosine rule, it's negative in front of the radical. You must choose. I've said this 7 times today. If you can't listen to that and can't make that choice correctly, it's on you at this point. Denoting what the biggest problem is of this section. And then cosine likes itself, so it's 1 plus the cosine of theta, and that's what I just put in there, or x. I keep saying theta. It's hard not to. And then guess what? It's still 8 over 8, but now this becomes 3 over 8 over 16. I could do that because I just did this, and it's negative. I know I forgot to write that. So that's that answer. Again, this has to come from your brain. It will not naturally happen. You must choose wisely. You know how you find tan? What's tan? Anyone? Tan is, anyone? Sine over, why wouldn't you just do this then? Root 13 over 4 divided by negative root 3 over 4. By the way, what's tan in quadrant 2? Positive or negative? What's tan in quadrant 2? Didn't it naturally happen? Right? And then this becomes root 13 over root 3. 4's cancel. Negative. And then multiply top and bottom by root 3. That's a 3. Free. I don't know what to tell you. This is what we got to do. Okay, got to move faster. All right, so we got to go to this next page and show you how these trick, and I'm going to do these 4. What time is it up there? Yikes. Oh, I have 20 minutes? It's like an eternity in here. Didn't I talk about Planck time in here? Sometimes you guys feel like this is Planck time, right? 1 second feels like a million. Never mind. That was Thursday? Talked about Planck time? Yeah. Someone's making noises with their tongue. By the way, 724. Anyone? Anyone know what the 724 Pythagorean triple is? It was the 4th one that I'd write on every page. 3, 4, 5, 5, 12, 13, 8, 15, 17, and then 7, 24, 25. Those are the 4 most common Pythagorean triples. And then, by the way, you would have to be in quadrant 1 because that's the rules for inverse tan of a positive. You'd have to be in quadrant 1. But then what is this? This is some mystery angle we'll call theta that we never find. And then what I'm able to do is, and I'm going to do 2 things. You know what cosine squared means? Means you cosine this angle measure, which is now half of theta. This is this mystery theta that I don't know. So inverse tanning this gives me this angle. All right? And then I'm going to cosine that angle divided by 2 and then square the answer. So what I'm doing is getting this ready for me to simply do. I can do it. It's easy. All right? Okay, here's the question. What's a positive squared? I need my, where's my phone at? I needed the Cricket app on that. The kids don't know what a positive squared is, obviously, in here. What's a positive squared? What's a negative squared? I don't have to get the crickets? Okay. You're right. What's the point of me asking that? Because the formula is plus minus. Does it matter if it's plus or minus when you're squaring it? No. It's actually a beautiful thing. Square root of cosine likes itself. So it's 1 plus cosine theta. I'm going to write this, and that just means I access this triangle information. How do I do theta over 2? I got to go to the theta triangle. All right? And then all over 2, and then squared. All right? So then I get to plug that in. So it's one more time. Plus minus square roots 1 plus cotan is 24, or cosine is 24 over 25. Cosine, struggling with my words. Squared. And what does that squared do? It basically nullifies all of this. All right, so there's no more radical at all. Bless you. All right, and then this is 25 over 25. I'm going to go ahead and write that. So this is 49 over 25 over 2. And if you ask me, where did that square root go? You did not watch this. These cancel, and then a positive and a negative squared is still a positive anyway. Bah. All right, and then this ends up being 49/50ths. Wild, weird, wacky stuff. This is just usage of the formulas. Very similar day on. I think this is more complicated than Friday, though. But I may be wrong. I may be forgetting something. All right? Let's say at least as complicated. All right? Maybe you just like the sound of my melodious voice. I've had sinuses the last 4 days, so a little scratchy. Okay, what quadrant do I have to be in for a positive ratio? It's got to be 1. It's the rules. Okay? Inverses have rules. And then this is root 7 over 5. 25 minus 7 is 18. Square root of that. I'm not teaching the Pythagorean theorem anymore. Square root of 9 is 3. 3 root 2. Okay? Again, I can't. I can't. Tan. Remember, this is some sort of theta. So when I inverse sine this stuff, it gives me that angle. I don't get to know what that angle is for a moment. But what I could do is use this triangle to fill in the next information. Right? And then, therefore, I could evaluate. Oh, dear. I did just write it. Is one of the three 1 minus cosine theta over sine theta? Is that right? Is that right? Does the other one have minus in it? Do they both have minus? Or does one have plus? They both have minus? One's plus. So the other one's 1 plus cosine on the bottom and sine on the top? All right. So it's either 1 minus or 1 plus cosine, and then sine's by itself on these two formulas. And then if you get the first two, if you get these first two, how could you not get the third one? For memorization purposes, how could you not get this one? Doesn't even make sense to me. How you'd possibly miss the third one, how you'd miss this one when you are given these two, or know these two. Just those two over each other, all right? 1 minus cosine over 1 plus cosine underneath a square root. So just trying to help you on memorization. All right, and then I could go to this triangle, and then it's just going to be some rationalization and fraction work. So 1 minus, and then the cosine of this is 3 root 2 over 5. And then sine of theta is that given, root 7 over 5. That's it. I wouldn't choose the first one. It'd be a mess. What a disaster. All right? Awful. What would I multiply by first? 5. You get rid of the fractions first. Just take a step at a time. It's easy. This makes it real simple. So this becomes 5 minus 3 root 2 over root 7. And then, let's go green with some black in there. That little fancy marker. I guess that's more blue, like turquoise. And then the next thing would be multiplied. Wrong. I looked at the numerator for some reason. It's the denominator that I'm rationalizing. That would, yeah, it's even said weirdly. Okay, but that's 5 root 7. Minus root 2 times root 7 is just root 14. Nothing happens. No perfect squares. Over 7. 7 doesn't go into 5 or 3. You're done. That's it. Everyone okay? Some people look sleepy. Need to be in your group so you can be poking your friends during the notes. Why would I mark myself wrong on this question? What's wrong? What's giving me the shakes right now? You're missing a theta. Can't stand it. Can't stand it. I won't even do the last one, even though it probably is a bit of a challenge. I think it's a little overdone. There's a lot of weird ways you have to look at this stuff with these identities. 9 minutes. I think I had about that same amount of time last hour at this point, so I'm doing pretty good. So if the video works. Do we have a cosecant squared rule? Or no, do we have a cosecant of theta over 2 rule? No, but who do you have? Who's related to cosecant? Sine. And I think you know that we have to work with the left side. We got to use our rules. So it's 1 over, you know what else we're going to do? We're going to change this how I wanted you to look at what does sine squared mean? It means sine of the angle, then square. You're going to want to do that too. And then yet again, let me get the crickets out. What's a positive squared? What's a negative squared? Positive. It doesn't matter, the plus minus. So equals. Next thing is, we're going to go ahead and do 1 over plus minus. We're going to humor. Sine hates cosine. Negative. Just the way I have it memorized. And then squared. Oh, goodness. Look at this. Look at the right. Look at the left. Okay, look at the right. Look at the left. So number 3 is 1 over squared, square roots, plus and minus canceled. You just get this. And then my silly little friends, what's the last thing that I write? Flip. And what does that mean? You are 100% what? Done. Somebody said it. Extend that a little bit. I don't want to be sloppy there. Boom. You okay? Everyone all right? I love wearing this headset now. Now I get a nice little line in my hair the rest of the day. Looks good. It's a good look. You don't get to see my face here to see that that's happening, but I love Mondays. Good factors, anyone? Because what I try to, you want to show you how much of a buffoon I am? Is this the same thing as this? Is this the same thing as this? Yes or no? Is this the same as that? No. And I was thinking that at first, like, oh, that's one of our rules from Friday. And when you start with a false, what happens with your identity? It's destroyed. And then there's really nothing I can do as a teacher to get like points for you, because you started with a false statement, I guess is the best way I could say this. So here's what we should do. And I think with those over 2s, I'm going to go ahead and write this out. I'm going to write out what squared means and then FOIL. So this is what squared means, something times itself. So I'm giving myself, I want to visualize this because the theta over 2s are hurting my brain a little bit. But they don't play in this foiling game. And I'm going to do this on purpose. I'm going to take this times this, cosine squared of theta over 2, and I'm going to go a little out of order. What's a negative times a negative? This ought to be fun. What's a negative times a negative? Positive. And what's sine times sine? Why did I do that? What is this going to be going into my next step? Anyone know? What is that going to be going into my next step? Step 3. What's sine squared plus cosine squared? It doesn't matter what the angle measures are. 1. Okay, and that's why I did that. Now, just to choose colors, just to say, hey, I'm not done yet. What's this times this? That's a negative sine cosine. What's this times this? Another negative sine cosine. So that's negative 2 sine cosines, but the argument is over 2's. So these arguments don't get affected by the foiling. They're just place markers for an angle measure. It's the sines and the cosines that get squared. Okay, and then just for purposes of replacement, this is 1. And then this is minus, this is wild. Do you remember this from Friday? 2 sine cosine, that was a rule. What was 2 sine cosine from Friday? That was the sine double angle formula, right? So here's what I'm going to write right away. This is crazy. This is sine 2 theta rule. But theta in this case is theta over 2. Maybe I should put this in blue here so you understand how this happened. That's the argument for the double angle theorem. What's 2 times theta over 2? What's 2 times theta over 2? This is why we always end with exactly writing what the other side is. Through logical steps, your proof is perfect. Okay? Okay. So maybe we look on Friday, understand your mentality that you have to have. It's almost the same exact set of notes today and Thursday, but a completely different usage of different identities. All right, but using them in the same way. Recognition, substitution, evaluation, whatever you want to call it. Whatever the steps require.